Okay, so even answers 5.2. We're going to look at 6, 12, 66. We're supposed to find, this is a differential equation. It has a derivative in it. We're supposed to find the original y equation. And because it has an x and y in it, it's probably going to have x and y like implicit in our original function. So to do this, I suggest that we write with the Leibniz notation so that we can separate them easily. That means I'm going to have 4y dy equals, did y'all leave the negative over here?
I gave the negative.
Okay. So it doesn't matter. There's just one negative. They kind of wrote it in the middle, so it makes sense. It could go either way. So now I have put the y's on the left, the x's on the right. I have everything written down correct, I think. So now we can integrate both sides because they both have a dy or a dx. And we're going to get negative y squared, negative 2y, negative 4 over 2 is negative 2y squared on this side, equals x to the 3 halves over 3 halves, which means times 2/3, plus c. And so what did they do to get their answer? They just multiplied everything by 3, and then they left c as a new constant, c2 or whatever, which we don't need to do. So is this answer fine? Yes, this answer is fine. This answer that they gave, can you see that they're the same now? If we moved this y over here and the c over here, like c is just any number, I don't know what it is, so it doesn't matter. When I multiply by 3, this is 3c, but I didn't know what c was to begin with, so I can just call it a new constant. That's the weird, sticky part about it, yeah.
Which one would we see on the multiple choice question?
Probably this one, I'm assuming, given that the book wrote that, but I don't know. I mean, I think if you should always approach every multiple choice problem as if you didn't have the answers there. You should work it and then see what you can find. And I think that you would notice that this 2x to the 3 halves, this is just multiplied by 3. I mean, it's good to go do the problem so we can make that assumption, how to find the multiple choice. But this is a perfectly fine answer. And if it was an open-ended question, you can certainly stop here. The reason that they did that is, if you remember back to Algebra 1, when you did lines and you wrote them in standard form, right, you put them x and y on the same side. I think that that's a giant waste of time because it's the same thing. But this answer is fine. The answer they gave is the same. Okay, so 6. Did y'all really do okay then? Okay, yay. 12. 12. You're supposed to take what they gave in words and write in math and then figure it out. The rate of change of p, so that's dp, big P because it gave you a big P, with respect to t, is proportional to equals k 25 minus t. Now, how come I put that in parentheses and wrote it like this?
So like it's not simple.
Because it doesn't say inversely, right? But it's not 25, it's not k times 25 and then minus t without the parentheses. Proportionality is a multiplication deal, multiplication or division. So this had to be a unit, and the constant is multiplied by that. So direct variation, proportional, inverse variation, those are all multiplication things. So writing it in math, was that a problem? Okay. Right, so it's not equal to, it's equal to some multiple of. Now I need to have p's on one side, t's on the other. K is just k, so it can be on either side, but I'm not going to move it. So I'm going to have d big P equals k 25 minus t dt. This becomes a u substitution problem because I've got these things multiplied. This is just a constant. I can totally take that to the front if I want. I don't know what it is, but it's just a number. It can go like that. I could also separate these out and do it that way. They did it like U substitution where they wrote the answer like this. So if I were you, I probably, if I wasn't trying to match the answer, I would have said this. And then just integrated this to be 25t. So this would be P equals K times 25t minus t squared over 2 plus c. They've got 25 minus t all squared. With the minus in the front. I guess they're saying that this is a unit. I guess I did it wrong. If this is a unit, then we have to treat it as a unit and do U substitution. Now the C might take care of mine, but that's not the answer that they gave. It might be a good question for me to ask somebody who's more experienced than I am, because that's still a thing. So what they did, they said U substitution. Do what?
So there's no way in this that you know everything.
Definitely not. If we did U substitution, then this du dt would be negative t. So then we'd have, oh yeah, negative 1. Sorry, in my mind I was going negative 1 and I'm still thinking ahead. Thank you for that, Soriani. So now we can go the integral of dp equals k, the integral of u with a negative. I'm going to put, where do you want me to put that? In front of k? du. And then that becomes u squared over 2, and that's how they got the k over 2. P equals negative k u squared over 2. So that's going to be 25 minus t all squared all over 2 plus c, which is what they got. So that unit part, I'll check and see if I can make sense of that. Y is k over 2. So this u went to u squared over 2. So you could write it like this. You could just move the 2 to the front. It doesn't matter. Like this is the same if I draw the line big. Does that answer your question? You're still frowning.
If you move it to the front, how are they both?
This is negative k over 2 times this. So you could.
It's like when you do the product.
You could just do like that. It's still 25 minus t squared over 1, right? So I just wrote it over the whole thing. You could write it under this one. You could write it under that one. It doesn't matter. You could write it in the front. Anyway. So I'm going to assume this is because that was that unit I talked about at the beginning, but didn't carry through to here. Interesting. I might even play with some numbers, see if they end up being the same. Okay, then 66. Was multiple choice, and it says, which of the following is the solution to the differential equation? So we have dy dx equals 8x over y. So y dy equals 8x dx. So we've got y squared over 2, right? I didn't write my integral, but, and you don't have to. You can go from one to the next step as long as you know what you did. Just like we didn't used to add, write plus 2 to both sides. I could have gone on without writing that in there. This would be 8x squared over 2, so 4x squared plus c. And their answers are all interesting. They've got square roots and such. They gave us one more piece of information. They said where y of 2 equals negative 4. So y of 2 equals negative 4. So how do I work with that?
Do you plug in the 2 for the x values and then plug in negative 4 for the y values?
Right. And see what that ends up being. So right here, this is the y, this is the x. So y is 16 over 2 equals 4 2 squared plus c. 8 equals 16. So c equals a half.
Isn't it plus c? Wouldn't it be, that's c.
Oh, it's divided. It's not divided. Yeah, you're right. Okay, so I'm really discombobulated now. So what is that, negative 8?
Mm-hmm.
Oh, much better. Okay, so that helps me. Surely it does. Now if I rewrite my equation and see what I can match up, I have a lot of choices that have square roots. So if I have y squared over 2 equals 4x squared minus 8, how do I match that up with the multiple choice, right? How do you get y equals? Because that's what they're all y equals. So now we're back in algebra 2. How do we make it y equals? Okay, so multiply by 2. Now I'm definitely multiplying 8x squared minus 16. And then y is going to be the square root of 8x squared minus 16. Now when you take a square root, you do plus or minus. But tell me about my original slope. 2 and negative 4. It is negative.
If you put a negative in front, it works.
Do what?
If you put a negative
Yeah, because the square root function theoretically is going to have a positive slope. So you had to choose between them. So you had to choose between a and b. Oh, x is greater than the square root of 2. Is that the question? Why is it not b? Because a and b are similar. A and b. One is y equals negative the square root of 8x squared minus 16. And the other is the square root of 8x squared minus 16. How are y'all going to tell the difference? Do what? So the original points, 2 and negative 4.
You could plug it into the original slope equation.
Right. So what kind of slope do you get at 2? 2 gives you a negative slope. If you graph the positive version, what does that look like? Do you know? Whatever you get out is going to be increasing. No, is it going to be increasingly positive? I want it to be in my mind. And so the negative makes sense because it goes down. But it's got a shift. So now I'm curious about what it looks like. My calculator's gone again. Okay, so here is the positive version. And does that match the slope we were given?
2 negative 4.
Because the slope would be negative. So that's not it. And here's the negative one.
Oh, there it is.
Which it would be negative. here. So that one would take some extra figuring between the two to figure out which was positive and negative. Because they're essentially the same, right? And when you take the square root, you get plus or minus. You're just going to have to hope that your knowledge of functions lets you guess quickly that the positive version should be positive. I mean, the square root function should be positive. This just has such a steep slope here because of the extra stuff, the translations in the function.